Tonight, we're going to explore one of the most unsettling mysteries in all of science. It is not a mystery about what is out there. It is a mystery about what is not. The universe looks full. 200 billion galaxies turn slowly in the dark. Each one holds hundreds of billions of stars. Around those stars, trillions of planets circle in silence. Some of those planets sit in the habitable zone. Warm enough for water, old enough for life, common enough that the numbers feel almost absurd. Sextillions of stars, scattered across unimaginable distance. A universe that should be loud. But when scientists point their instruments at the sky and listen, they hear nothing. No signal, no pattern, no voice. 60 years of searching, and the silence has never once broken. By the end of tonight, you're going to understand exactly why the universe stays quiet, and why that silence might be the most frightening fact we have ever discovered. Before we get started, if you love exploring the depths of space as much as we do, take a second to like the video or subscribe. It's a simple action, but it helps this channel reach more curious minds like yours. So let's begin. Start with something small. A radio dish pointed at the sky, somewhere quiet, far from cities, far from interference. The dish is old technology, metal, motors, a receiver built from familiar parts. It does one thing, and it does it patiently. It listens. Not for a voice exactly, for a pattern, something that could not happen by accident. A signal repeating at a single frequency. A pulse arranged in a rhythm nature does not use. Anything that looks like it was sent on purpose. This has been happening since the 1960s. Astronomers built receivers, aimed them at nearby stars, and waited. The project eventually got a name. The Search for Extraterrestrial Intelligence. SETI, for short. At the time, the mood was hopeful. Life seemed likely. Intelligence seemed likely too. Given enough stars, someone should be transmitting. The first serious search happened in 1960. A young astronomer named Frank Drake pointed a radio telescope at two nearby stars, Tau Ceti and Epsilon Eridani, both similar to our Sun. He called the effort Project Ozma, after a fictional queen in a distant, hidden land. The name fit. He was listening for a kingdom he could not see. For weeks the telescope collected data, static mostly, the ordinary noise of the universe. Once, briefly, something strange spiked on the recorder. The room went tense. Then it turned out to be an aircraft passing overhead. Ordinary interference, nothing more. The search continued for years. Then, decades, better equipment came online. Larger dishes, sharper receivers, faster ways to process the data. By the 1990s, computers could scan millions of frequencies at once. Volunteers ran the analysis on their home machines. Millions of people donated their processing power without ever seeing a result. The scale of the search kept growing. Thousands of stars. Then hundreds of thousands. Now the search covers an enormous slice of the sky. Modern arrays scan across a wide range of frequencies, continuously, automatically. The Breakthrough Listen project, launched in 2015, is the most ambitious version yet. It uses some of the largest radio telescopes on Earth. It has examined over 1 million nearby stars. It has scanned the plane of our galaxy, where most of the stars live. It has listened toward other galaxies entirely, hoping to catch something powerful enough to cross that distance. The result, every single time, is the same. Nothing, no confirmed signal, no repeating pattern that couldn't be explained by natural causes or human interference. 60 years of listening. Trillions of data points. Silence, from every direction, at every frequency we know how to check. This should not make sense. The numbers say otherwise. There are 200 billion galaxies in the observable universe. Our own galaxy alone holds an estimated 400 billion stars. Recent estimates suggest most of those stars host at least one planet. That means our galaxy alone could contain trillions of worlds. Some fraction of those worlds sit at the right distance from their star. Not too hot, not too cold. Warm enough for liquid water to exist on the surface. Even a small fraction of trillions is an enormous number. Millions of potentially habitable worlds in this galaxy alone. Now multiply that by 200 billion galaxies. The number becomes almost impossible to hold in your mind. Sextillions of stars. That's a 1 followed by 21 zeros. A number so large it stops meaning anything to human intuition. And yet, across all of that, we have found no evidence of another voice, no structure we did not build, no light that shouldn't be there, no message, encoded or otherwise, just the hiss of background radiation and the quiet turning of stars that seem, as far as we can tell, entirely alone. This gap has a name. Scientists call it the Fermi Paradox. It comes from a lunch conversation in 1950. The physicist Enrico Fermi was eating with colleagues at Los Alamos. The conversation turned to flying saucers, a popular topic at the time. Then it turned to something deeper. If the galaxy is old and the numbers are large, where is everyone? Fermi did the math in his head roughly the way physicists do. He pointed out that a civilization capable of slow interstellar travel could cross the entire galaxy in a few million years. A few million years sounds long. It is not on a cosmic scale. The galaxy itself is over 10 billion years old. If even one civilization had emerged early and started spreading, it would have had time to visit every star system many times over. It should be everywhere by now. And yet, it is nowhere. That gap between what should be true and what we actually observe is the paradox. It has never been resolved. Every year, scientists propose new explanations. None of them fully satisfy. The most popular explanation involves something called the Great Filter. The idea is simple and deeply unsettling. Somewhere between lifeless chemistry and a civilization capable of reaching the stars, there is a barrier, a step that is almost impossible to cross. Something filters out almost everyone who tries. The terrifying part is that we do not know where the filter sits. It might be behind us. Maybe the origin of life itself is the hard step. Maybe simple chemistry rarely becomes biology, and Earth got lucky in a way that almost never happens. If that's true, we are rare. Precious, but rare. The silence would make sense, because there is almost no one else to hear, or the filter might be ahead of us. Maybe life is common, and simple life is common, and even intelligence is common. Maybe the hard step is something else entirely. Maybe every civilization that reaches our level of technology eventually destroys itself. Nuclear weapons, engineered pathogens, runaway artificial systems no one can control, climate collapse from unchecked industry. If the filter is ahead of us, then the silence is not comforting. It is a warning. It would mean that every civilization that ever rose this far went silent shortly after, and we are walking the same path toward the same wall. There is no way yet to know which version is true. We only have one data point. Ourselves, and one data point cannot tell you where you sit on a curve. The uncertainty itself is part of what makes this so heavy to sit with. It is not a story with a villain, or a monster, or an enemy fleet. It is a statistic with a shape we cannot see, and we are somewhere inside it, unable to check our position. Some researchers have tried to sort the possible explanations more carefully. They group them into a few broad categories. The first is simple. We are alone, or nearly alone, because life is far rarer than the numbers suggest. The second is more unsettling. Life is common, but intelligence is rare. The third is the darkest. Life and intelligence are both common, but something stops civilizations from lasting. There is a fourth possibility, quieter than the rest. Maybe they are out there and simply have no reason to reach us. Consider the distances involved. Even our nearest star system, Alpha Centauri, sits 4.2 light-years away. Light itself takes over 4 years to cross that gap. Our fastest spacecraft, moving at tens of thousands of miles per hour, would take over 70,000 years to arrive. 70,000 years is longer than all of recorded human history, several times over. That is our nearest neighbor. Most stars in the galaxy sit thousands of light-years away. A radio signal, moving at the speed of light, would take thousands of years just to arrive. A reply would take thousands more. Imagine trying to hold a conversation where every sentence takes 10,000 years to deliver. No civilization, however advanced, escapes that limit. The speed of light is not a technological problem. It is a property of the universe itself. Nothing with mass can reach it. Nothing can exceed it. This single fact reshapes everything about contact. Even if 1,000 civilizations exist right now in our galaxy, most of them are so far away that a signal from them, sent today, would not reach us for millennia. And a signal from us would take just as long to reach them. By the time any reply arrived, the civilization that sent the original message might already be gone. Empires rise and fall in centuries. 10,000 years is enough time for a civilization to appear, flourish, and vanish entirely, all before its signal even reaches its intended audience. Contact does not simply require someone to be out there. It requires two civilizations to exist at the same cosmic moment, close enough that a signal can cross the gap within a meaningful span of time, both listening, both transmitting, both patient enough to wait centuries for a reply. The odds of that alignment are staggering. Space is not just large, it is large across time as well as distance. A star 1,000 light-years away is not just far. It is a message from 1,000 years in the past, arriving into whatever we have become by the time it gets here. Even our own radio signals, the ones we have been broadcasting for less than a century, have only traveled about 100 light-years outward. 100 light-years is nothing on a galactic scale. Our galaxy is over 100,000 light-years across. Our loudest broadcasts have reached barely a fraction of 1% of it. We are, in the truest sense, whispering into an ocean. And here is where the picture grows even darker. The universe is not standing still. It is expanding, and it has been expanding since the beginning of time. Every galaxy, on average, is moving away from every other galaxy. Not because they are flying through space, but because space itself is stretching between them. This is one of the strangest facts in all of physics. Galaxies are not racing away from us because we are unpopular. The fabric they sit in is growing, carrying them apart the way raisins in rising bread are carried apart by the dough itself. This expansion is not slowing down. For decades, scientists assumed it would. Gravity should pull everything back together. Eventually, the way a ball thrown into the air eventually falls. In 1998, that assumption broke. Astronomers studying distant exploding stars discovered something impossible. The expansion of the universe is accelerating. Something is pushing space apart faster and faster, and no one fully understands what it is. Scientists call it dark energy. The name is really just a label for our ignorance. It makes up about 70% of everything in the universe, and we cannot see it, touch it, or explain it. We only know its effect. Space stretches faster every year. Because of this acceleration, distant galaxies are not just far away. They are receding from us at increasing speed. Some galaxies, at extreme distances, are already moving away from us faster than light can travel. This does not break physics. Light itself is not exceeding its speed limit. Space is simply expanding between us and them so quickly that light from those galaxies will never reach us, no matter how much time passes. They have already crossed a horizon we cannot see past. This horizon has a name. Cosmologists call it the cosmic event horizon. Beyond it, nothing can ever reach us. No light, no radio wave, no signal of any kind sent by any civilization, however advanced. The information is gone, not lost in distance, but placed permanently beyond reach. And the horizon is closing. Slowly, but constantly. More galaxies cross that boundary every year. Right now, there are galaxies visible in our telescopes that we can still see, but that are already moving away fast enough that any light they emit today will never reach Earth. We are watching them fade from contact in real time, even though their light still arrives from the past. Give this enough time, hundreds of billions of years, and the sky itself will empty. Every galaxy outside our own small cluster will eventually vanish beyond the horizon. A civilization born far enough in the future, inside some distant galaxy, might look up and see nothing at all. No other galaxies. No proof the universe was ever anything but their own small island of stars. They would have no way of knowing that trillions of other galaxies ever existed. The evidence would simply be gone, carried away by the expansion of space itself. We are lucky, in a strange way, to exist now, early enough in the universe's history that the sky is still full of galaxies we can observe. Future civilizations will not have that luxury. Their universe will look smaller, emptier, and far lonelier than ours. This changes the meaning of the silence. It is not only that other civilizations might be too far away, or too brief, or too rare. It is that the universe itself is actively working to separate everything from everything else. Permanently, a little more each year. Even if two civilizations exist at the same moment, close enough to reach each other today, the window will not stay open forever. Eventually, the space between any two galaxies will stretch beyond the point where light can cross it in a finite time. Contact has an expiration date, built into the structure of the cosmos itself. This is not the plot of a story. It is measured, published, repeated science. The universe is not just big. It is actively becoming more isolated, more empty, more silent, and there is nothing anyone can do to stop it. There is a deeper force at work here too, one that reaches beyond distance and beyond expansion. It is called entropy. Entropy is, in simple terms, a measure of disorder. Every closed system in the universe tends toward more disorder over time, never less. A hot cup of tea left on a table always cools down. It never spontaneously heats up on its own. Ice always melts in a warm room. It never spontaneously forms from water sitting in the sun. This is the second law of thermodynamics, and it applies everywhere, without exception. It applies to stars, it applies to galaxies, it applies to the universe as a whole. Stars burn because they are converting order into disorder, fusing hydrogen into helium, releasing energy as they go. Every star is, in a sense, spending down a finite fuel supply that took billions of years to accumulate and will eventually run out. Our own sun has enough fuel to keep burning for another 5 billion years or so. Then it will swell, cool, and eventually collapse into a small, dense ember called a white dwarf. It will glow faintly for trillions of years after that, slowly losing its remaining heat into the cold of space. Every star in the universe faces some version of this fate. The smallest stars, the red dwarfs, burn so slowly that some of them could theoretically last for trillions of years. But even they will eventually run out. Star formation itself is slowing down. The universe made most of its stars long ago. in a burst of activity billions of years back. New stars are still forming, but at a fraction of the old rate, and that rate keeps dropping. Eventually, the raw material for new stars, the great clouds of hydrogen gas, will run out entirely. When that happens, no new stars will ever form again. The stars that already exist will slowly die out, one by one, over spans of time so long they barely fit inside language. Trillions of years from now, the last red dwarfs will fade. The universe will fill with the cold, dark remnants of everything that ever burned. Black holes, neutron stars, white dwarfs, all slowly leaking their remaining energy into the void. Even black holes are not permanent. They lose mass over unimaginably long timescales, through a process called Hawking radiation. Eventually, even the largest black holes will evaporate entirely. This is a timescale so long, it makes the age of the universe so far look like a single second. Trillions upon trillions of years. At the very end of this process, physicists describe a state called heat death. Every star extinguished, every source of usable energy exhausted. Matter spread so thin across an endlessly expanding universe that particles rarely, if ever, meet each other again. Temperature approaching absolute zero everywhere, evenly, with nothing left to create the differences that make motion, change, or life possible. No warmth, no light, no structure. Just a thin, cold, silent expanse, stretching on forever. In that far future, there is no one left to listen for anyone else, because there is no one left at all. The silence we hear tonight, the silence from our radio telescopes, is only the earliest whisper of a silence that will eventually become total and permanent. We happen to exist in a narrow, warm window near the beginning of an unimaginably long story, when stars still burn and energy still flows, and life is still possible at all. That window will not stay open. It never does. Every star is a countdown. Every galaxy drifting away is a door quietly closing. Every year of silence from the sky is one more year added to a wait that may never end. Knowing all of this changes the meaning of the search. The radio dishes are not simply hoping to find someone. They are racing against distance, against expansion, against the slow decay of everything, hoping to catch a signal in the brief window when it is still possible for one to arrive. And still, night after night, decade after decade, the receivers pick up nothing but static. Some scientists take comfort in that silence. If the great filter lies behind us, in the difficulty of life ever beginning at all, then our existence is something close to a miracle, and the silence is simply what a mostly empty universe should sound like. Others find the same silence far more frightening. If the filter lies ahead of us, in some barrier every advancing civilization eventually hits, then the silence is not proof that we are alone. It is proof that no one gets far enough to be heard for very long. There is no way yet to know which explanation is correct. Every year, new evidence adds a little more nuance, a little more data, and still no definitive answer. Missions continue to search for signs of life on other worlds. Telescopes examine the atmospheres of distant planets, looking for gases that would suggest something living produced them. Oxygen, methane, combinations that should not exist together without something maintaining the imbalance. So far, nothing conclusive has been found. Every candidate signal, every strange result, has eventually been explained by something ordinary. A satellite, a comet, an unusual but natural chemical process. The universe keeps offering false alarms, and never once a confirmation. Meanwhile, the search keeps expanding. New telescopes, more sensitive than anything before them, are coming online in the next decade. They will examine more planets, more frequencies, more of the sky than ever before. If there is a signal to find, humanity's chances of finding it are only improving. But so is our understanding of just how difficult that search really is. Every year, the numbers get more precise, and the challenge only grows larger in scope. Consider, for a moment, the sheer scale of what a single galaxy contains. 400 billion stars in our galaxy alone. If a single alien radio broadcast right now is traveling toward Earth from somewhere near the galaxy's center, it has a journey of about 26,000 years ahead of it. Minimum, that signal, if it exists, was sent before written history began. Before agriculture, before cities, before anything we would recognize as civilization. Whoever sent it, if they still exist at all, has had 26,000 years to change beyond recognition, or to vanish entirely. We would be listening to a voice from a world that may no longer exist in any form we could identify. This is the strange nature of looking outward. Every observation of deep space is also an observation of deep time. Every galaxy we see is a fossil of the past, not a picture of the present. The stars in the night sky are not a live broadcast. They are old letters, still arriving, written by senders whose current condition we cannot know. Some of those stars may have already died. The light we are seeing tonight left them long before we existed at all, and is only now reaching a planet capable of noticing it. This is true for radio signals as well. If contact ever does arrive, it will be a message from someone's past, not their present. We will never truly speak to another civilization in real time. We will only ever exchange old letters, sent across gulfs of time too large to bridge with anything faster than light. Even a friendly, curious, communicative civilization somewhere out there faces the same walls we do. The same distances, the same expanding space, the same slow decay of stars and energy. If they are listening for us, they are hearing our silence just as clearly as we hear theirs. Our own radio signals are still only 100 light years out. To almost the entire galaxy, humanity has not made a sound yet. We are, from the perspective of most of the universe, still completely silent ourselves. That thought reframes the entire question. We have been asking why no one has spoken to us. Perhaps the better question is why we expected anyone to have heard us at all. We are a young species, on a young signal, in an old and enormous galaxy, inside an even larger universe that is actively pulling itself apart. Given all of that, silence might not be a mystery. It might simply be the default condition of everything. Not a void full of absent friends. Just space, doing what space does, at a scale where presence and connection are the rare exception, and emptiness is the ordinary rule. There is something almost calming in that reframing, even inside the unsettling parts. If contact is this difficult by the very nature of physics, then its absence is not a judgment on us. It is not proof of failure, or unworthiness, or mistake. It is simply what geometry and time produce, applied at a scale too large for any one mind to fully picture. We are not unheard because we are unremarkable. We are unheard because the universe was built, from its very first moment, to keep almost everything apart from almost everything else. That was true before life ever began. It will remain true long after every star has gone dark. The silence is not personal, it is structural. And there is something in that distinction worth holding on to quietly. Tonight, consider the history of our own small planet for a moment. Earth formed about 4.5 billion years ago, out of dust and gas left over from the sun's own birth. For hundreds of millions of years, it was a molten, hostile place. Asteroids struck constantly. The surface had no solid crust yet, only rivers of liquid rock. Somewhere in that violence, water arrived, carried in by ice-laden comets and asteroids from the outer solar system. oceans formed. The planet cooled, slowly, unevenly, over millions of years. Then, somewhere between 3 and 4 billion years ago, something happened that we still do not fully understand. Chemistry became biology. Simple molecules arranged themselves into something that could copy itself. Something that could hold information and pass it forward. That single event, life's origin, has never been observed happening a second time. We do not know if it happened once, by extraordinary chance, or if it happens constantly, wherever the right conditions exist. We only have one confirmed example, and it is the ground we are standing on. For the next 2 billion years, life on Earth stayed simple. Single cells, drifting in shallow water, doing very little that looked like progress. No plants, no animals, no shells, no bones, no eyes, just quiet chemistry, repeating itself, generation after generation, in an ocean with no witnesses. Then, around 2 billion years ago, something else happened. Simple cells learned to live inside other simple cells, cooperating instead of competing. This partnership eventually produced complex cells, the kind that make up every plant and animal alive today. Scientists call this event endosymbiosis. It may have happened only once in the entire history of life on Earth. If it never happens again, complex life may be one of the rarest events in the universe, harder to produce than life itself. Every animal, every plant, every visible living thing on this planet descends from that single ancient partnership. If that step had failed, Earth might still be a world of nothing but simple, single-celled organisms today, 4 billion years later. A planet teeming with life by one definition, and yet utterly incapable of ever building a radio telescope. This is one version of the Great Filter, hiding in our own deep past. Maybe most living worlds get this far, and no further. Endless oceans of simple life, never combining into anything more complex, for billions of years, forever. If that is common, the universe could be full of biology, and still be almost entirely silent. Because none of that biology ever learns to ask questions, or build tools, or point instruments at the sky. Even after complex life appeared on Earth, the road to intelligence was neither fast nor guaranteed. Complex organisms filled the oceans for hundreds of millions of years before anything resembling a nervous system existed. Brains, when they finally appeared, were simple at first. Barely more than a knot of nerves, enough to sense light, or movement, or the presence of a predator. Intelligence, in the sense we mean, it took far longer still. Dinosaurs dominated this planet for over 150 million years. Not one of them built a tool, wrote a symbol, or left behind anything resembling technology. They were successful in every biological sense. They were not, by any measure, on a path toward radios or spacecraft. It took a specific and unlikely disaster, an asteroid strike 66 million years ago, to clear the way for mammals to expand into the niches dinosaurs had occupied. Without that asteroid, there is no guarantee intelligence as we know it ever would have emerged on this planet at all. Even after mammals took over, it took tens of millions of years before anything resembling human intelligence appeared. Early primates, then early hominins, then, only a few 100,000 years ago, something close to modern humans. Civilization itself, in any recognizable form, is only about 10,000 years old. Radio technology is barely more than a century old, set against 4.5 billion years of Earth's history. Human civilization is a flash, a single spark near the very end of an extraordinarily long fuse. If you compressed Earth's entire history into a single 24-hour day, life would appear sometime in the early morning. Complex life would not appear until late afternoon. Dinosaurs would rule for less than an hour, near the end of the evening. Humans would appear in the last few seconds before midnight. Radio technology would exist for a fraction of the very last second. This is the timescale intelligence actually requires, at least on the one world where we have watched it happen. Every step along that path could plausibly have failed. The origin of life could have failed. The rise of complex cells could have failed. The survival of early life through repeated mass extinctions could have failed. The asteroid that cleared the way for mammals might never have struck at all. Any early hominin species could have gone extinct before intelligence ever developed further. We do not know how many of these steps are common and how many are extraordinarily rare. We only know that on this one planet, every single one of them happened to go the way it needed to, for us to eventually exist and start listening to the sky. This is why some researchers now believe the filter sits behind us, buried somewhere in our deep evolutionary past. If that is true, complex intelligent life may be staggeringly rare, not because planets are rare, and not because life itself is rare, but because the specific chain of unlikely events required to produce something like us almost never completes. Under this view, the silence is almost gentle. It says we are simply uncommon, the way a specific, rare flower is uncommon in a vast forest, not because the forest is hostile, but because that particular bloom needs an unusual combination of conditions that rarely align. But there is another possibility, and it does not offer the same comfort. What if the hard steps behind us were not actually so hard? What if life begins readily, wherever chemistry allows it? What if complexity and nervous systems and intelligence all tend to emerge given enough time, the way water tends to find the lowest point in a landscape? Under this view, the universe should be full of minds, full of civilizations, at every stage of development, scattered among the stars. And if that is true, the silence stops being gentle. It becomes a warning, pointing towards something ahead of us, rather than behind. Researchers who study existential risk have spent decades trying to identify what that barrier might be. Nuclear weapons are the most obvious candidate. Within a single century of splitting the atom, humanity built enough warheads to end civilization many times over. For decades, the two largest nuclear powers kept enough weapons ready to launch within minutes, guided by systems that occasionally and quietly reported false alarms. More than once, a single human being made a judgment call that avoided catastrophe by pure chance and clear thinking, under enormous pressure, with very little time to decide. If any civilization anywhere reaches nuclear capability before it reaches the political maturity to manage it safely, that step alone could be a filter. Not a guaranteed extinction, but a repeated near miss, generation after generation, until eventually the luck runs out. Biological weapons pose a similar risk, arguably worse, because the barrier to creating them keeps getting lower as technology improves. Engineered pathogens, designed to spread further and kill more efficiently than anything nature produces on its own, could in principle end a civilization without any single actor intending global catastrophe. A laboratory accident, a miscalculation, a single act of malice, amplified by tools that grow more accessible every year. Climate instability offers a slower, quieter version of the same risk. Not a single dramatic event, but a gradual undermining of the systems every civilization depends on to feed itself, to build, to organize, to survive. A civilization does not need an asteroid to fall. It can simply erode the conditions that allow it to function, slowly enough that by the time the danger is undeniable, the momentum is already difficult to stop. There is a newer concern as well, one that did not exist in Fermi's time. Artificial systems, built to optimize toward goals, but without a full understanding of what they might do once they become powerful enough to act on their own. Some researchers worry this could be the sharpest version of the filter yet, a threshold every sufficiently advanced civilization eventually crosses, where the tools built to solve problems become difficult to constrain. and difficult to reverse. We do not know if any of these risks are truly civilization ending. We do not know if a civilization more advanced than ours would find better solutions than we currently have. We only know that every year, a species capable of ending itself has more tools available to do exactly that, and no confirmed example, anywhere in the universe, of a civilization that has proven it can survive its own technology for very long. This is the darkest interpretation of the silence. Not that no one exists, but that existing, at our level of technology, comes with a short shelf life. That every civilization eventually builds the tools capable of ending itself. And most of them, sooner or later, do. If that is true, the silence is not comforting. It is a graveyard we cannot see, filled with civilizations that reached exactly where we are now, and then stopped, one after another, each one going quiet within a few centuries of learning to speak at all. There is no way, currently, to know if this is our future. There is also no way to know that it is not. We sit inside the uncertainty, aware of the danger, without a map that tells us whether we are already past the hardest part or standing directly in front of it. Some scientists have tried to put numbers on all of this using something called the Drake equation. Frank Drake developed it not long after his first search as a way to organize the guesswork into something structured. It multiplies together several factors: the rate of star formation, the fraction of stars with planets, the fraction of those planets that could support life, the fraction where life actually appears, the fraction where life becomes intelligent, the fraction where intelligence develops technology capable of sending signals into space, and finally, how long such a civilization continues broadcasting before it falls silent, whether from collapse, self-destruction, or simply moving on to other forms of communication we might not detect. Plug in optimistic numbers, and the galaxy should be humming with thousands of civilizations. Plug in pessimistic numbers for even a few of those factors, and the expected number of civilizations collapses toward one. Us alone, the equation does not solve anything. It simply organizes our ignorance into a shape we can examine. And the honest answer, after 70 years of trying, is that we still do not know most of these numbers with any real confidence. We are guessing, carefully, using the best tools available, at a question the universe has not yet agreed to answer. Set the question of who is out there aside for a moment, and consider a different problem. Even if life exists nearby, even if intelligence exists nearby, distance alone might keep us apart forever. Nearby, in cosmic terms, is a strange word. Our nearest star system, Alpha Centauri, is often described as close. In truth, it sits 4.2 light-years from Earth. Light-years measure distance, not time, but the distance is so large that light itself becomes the only reasonable ruler. 1 light-year is about 6 trillion miles. 4.2 light-years is roughly 25 trillion miles. Try to picture that distance for a moment. If you shrank the sun down to the size of an orange, Earth would be a grain of sand, about 30 feet away. On that same scale, Alpha Centauri would be another orange, sitting roughly 1,500 miles from the first. That is the distance to our closest neighboring star. Every other star in the galaxy is farther still. Our fastest human-made spacecraft, the Parker Solar Probe, moves at over 150,000 miles per hour at its closest approach to the Sun. That is faster than any object humans have ever built. At that speed, a trip to Alpha Centauri would still take about 18,000 years. 18,000 years ago, humans had not yet invented agriculture. We were living in small bands, following herds, thousands of years before the first city would ever be built. A journey to our nearest star, at our fastest current speed, is longer than the entire span of human civilization, several times over. And that is our closest neighbor. Most stars capable of hosting life sit thousands of light years away, scattered across the galactic disk. Some ideas exist for traveling faster. Nuclear propulsion, in theory, could push a spacecraft to a meaningful fraction of the speed of light. Even at 10% of light speed, a genuinely difficult engineering target, a trip to Alpha Centauri would still take over 40 years. A trip to a star 1,000 light-years away would take 10,000 years. Even under those optimistic assumptions, no human alive today would see the ship arrive. Neither would their grandchildren or their grandchildren's grandchildren. Whoever eventually reached the destination would be descendants of the original crew, born generations into the voyage, on a ship that had become the only home they had ever known. This idea has an actual name. Scientists call it a generation ship, a vessel built not for one crew, but for hundreds of crews, born and raised entirely within its walls, tasked with maintaining a journey none of them chose, and none of them will see completed. Every problem on Earth, food, air, water, waste, social order, would need to be solved inside a sealed metal shell for centuries, without any possibility of resupply. A single serious failure, decades into the voyage, could doom every person aboard, including generations not yet born. No one has ever attempted anything like this. It remains, for now, entirely theoretical, a solution on paper to a problem that paper cannot fully solve. Even faster theoretical methods run into walls of their own. Antimatter propulsion could, in principle, push a ship to a significant fraction of light speed, but producing and storing enough antimatter remains far beyond current technology, and likely will remain so for a very long time. Concepts like generation-scale fusion drives exist mostly in physics papers and engineering thought experiments, not in any working hardware. Faster than light travel, the kind imagined in fiction, appears to violate the basic structure of physics as we currently understand it. Nothing with mass can reach the speed of light, let alone exceed it, according to every theory that has so far survived experimental testing. Some theoretical loopholes exist on paper, exotic solutions involving warped space rather than fast motion. But every version proposed so far requires forms of matter and energy that have never been observed to exist. For now, and likely for a long time to come, the speed of light remains an absolute limit, not a suggestion. This changes what contact would actually require.
It is not enough for another civilization to exist. It must exist close enough, in both space and time, that a signal, or a ship, could plausibly cross the distance within a span either species could reasonably wait for. A civilization 100,000 light-years away might as well not exist at all for any practical purpose, because nothing either side does today could ever be answered within any lifetime, any generation, or perhaps any civilization's total lifespan. Even radio waves, moving at the fastest speed anything can move, are bound by the same limit. A message sent today toward a star 1,000 light-years away will not arrive for 1,000 years. Any reply will take another 1,000 years to come back. 2,000 years minimum for a single exchange. Human civilization has existed, in any recognizable form, for roughly that long, twice over. The pyramids at Giza are older than that. Whole languages have been born and died within spans shorter than a single round-trip conversation across that kind of distance. This is why some scientists argue that even a universe full of intelligent life could remain almost entirely silent to us, simply because of timing. For contact to succeed, both civilizations must be broadcasting, or listening, during an overlapping window measured in centuries, out of a galaxy that has existed for over 10 billion years. That window is a sliver, a heartbeat, inside an ocean of time so large that most of it holds nothing recognizable as civilization at all. Even if the galaxy has hosted 1,000 civilizations across its entire history,
The odds that any two of them existed at the same time, close enough to notice each other, are vanishingly small. Most would have risen and fallen in complete isolation, each one alone in its own moment, separated from every other civilization, not just by distance, but by time itself. It is possible that somewhere out there, right now, another civilization is listening to its own version of static, wondering exactly what we are wondering. Unaware that 100 light years away, a young species just started broadcasting radio signals of its own. By the time that signal reaches them, if it ever does, both civilizations may have changed beyond recognition, or one of them may no longer exist at all. Contact, if it ever happens, will almost certainly not feel like a conversation. It will feel like an old photograph, arriving decades or centuries after it was taken, of a place and a people who may already be gone. Now widen the frame again, past individual stars, past single galaxies, out to the structure of the universe itself. The universe began, as far as our best evidence shows, about 13.8 billion years ago. In an instant, all of space, all of time, and all of matter came into existence together, expanding outward from a state so dense and so hot that physics as we understand it barely applies. Cosmologists call this event the Big Bang. It is not an explosion happening inside space. It is the beginning of space itself, stretching outward from that first instant, carrying everything within it along for the ride. In the earliest fractions of a second, the universe underwent a period of extraordinarily rapid expansion, called inflation, growing by an almost unimaginable factor in a fraction of a second. After that, expansion continued at a steadier pace for billions of years as matter cooled, atoms formed, and eventually stars and galaxies began to take shape. For most of the universe's history, gravity was slowing that expansion down, pulling everything back toward everything else, the way gravity always tries to pull matter together. Then, roughly 5 billion years ago, something changed. The expansion stopped slowing. It started speeding up instead. Distant galaxies began moving away from each other faster with each passing year. Not because they were being pushed by anything we can point to directly, but because whatever dark energy actually is, it appears to work more strongly as space itself grows larger. The more space there is, the more of this mysterious force there seems to be, and the faster the expansion accelerates. This creates a feedback loop with no natural end. More expansion creates more dark energy effect. More dark energy effect creates more expansion. Round and round forever, with no force currently known that could reverse it. The consequences of this accelerating expansion unfold over almost incomprehensible timescales, but they are consequences nonetheless, and they are already beginning. Right now, within our own local group of galaxies, a cluster held together tightly by gravity, things are stable. Our galaxy, the Milky Way, is actually on a slow collision course with our largest neighbor, the Andromeda Galaxy, expected to merge with us in roughly 4 to 5 billion years. Gravity, at this local scale, is still stronger than the expansion trying to pull everything apart. But beyond our local group, the story is different. Every other galaxy cluster, every other supercluster is drifting away from us and from each other at an ever-increasing rate. Over the next 100 billion years, the distance between galaxy clusters will grow so large and their relative speed will grow so fast that light from those distant galaxies will simply stop being able to reach us at all. Not because the light is too weak, not because our telescopes are not sensitive enough, but because the space between us and them will be expanding faster than light can cross it. This is the cosmic event horizon mentioned earlier, and it is worth sitting with the true shape of what that means. A horizon like this is not a wall or a fence or an edge to the universe. It is a boundary defined entirely by speed and distance, a point beyond which no signal of any kind, sent by any means, can ever arrive here again. Anything beyond it is not merely far away. It is functionally gone, as far as any future observer on Earth, or anywhere near it, will ever be able to tell. Scientists estimate that within about 100 billion years, nearly every galaxy outside our own local group will have crossed this horizon. The night sky, which currently shows hundreds of billions of other galaxies to our telescopes, will eventually show none at all. Just our own merged galaxy, sitting alone in an ocean of black, with no evidence remaining that anything else ever existed. A civilization born in that distant future would have no way of discovering the rest of the universe, unless they inherited records from an earlier, more fortunate age. They would look at their instruments, study every wavelength of light available to them, and conclude, reasonably, that their galaxy was the only one that had ever existed. They would be wrong, but they would have no way of knowing it. The evidence would already be gone. Not destroyed, simply placed forever out of reach by the geometry of an expanding universe. This should reshape how you think about tonight's silence. It is easy to imagine the lack of contact as a failure of searching, a problem of not looking hard enough or not waiting long enough. But the universe itself is actively working against connection, on a timescale far longer than any civilization, pulling everything apart, one light year at a time, forever. Even a universe teeming with life, densely packed with intelligent civilizations at every stage of development, would still struggle against this expansion. Given enough time, every civilization's neighbors would eventually vanish beyond their own local horizon, leaving them just as isolated as if they truly were alone from the very beginning. Isolation, on a long enough timescale, becomes the default state of everything. Not because life is rare, but because space itself insists on it. This is not a temporary condition we might one day overcome with better engines or clever signals. It is baked into the structure of the cosmos, present from nearly the first moment, and it only grows stronger with every year that passes. The silence we hear tonight, from our small radio dishes pointed at a mostly empty sky, is a preview of a silence that will eventually become total. Not just for us, but for anyone, anywhere, who happens to still be listening billions of years from now. There is one more force working against connection, quieter than distance, quieter than expansion, but just as certain. It has nothing to do with how far apart things are. It has to do with how much usable energy remains in the universe at all. Every process that makes life possible, every heartbeat, every thought, every star's light, depends on something called a gradient. A gradient is simply a difference: hot next to cold, bright next to dark, ordered next to disordered. Energy always flows from the ordered side toward the disordered side, evening things out, the way heat flows from a hot cup of tea into a cooler room until both reach the same temperature. Once everything reaches the same temperature, the same density, the same level of disorder, nothing can flow anymore. There is no more difference left to drive any process forward. This state has a name. Physicists call it maximum entropy, or more simply, heat death. Every living thing on Earth survives by using a gradient. Plants use the difference between the hot surface of the sun and the cold darkness of space, capturing a tiny fraction of that flow of energy as it passes through on its way to being evenly spread out. Animals eat plants, or eat other animals, using the ordered chemical energy stored in their bodies, releasing it as heat, contributing, in a small way, to the universe's slow drift toward sameness. Every action taken by every living creature that has ever existed has been, in a very real sense, borrowed time, drawn from a limited supply of order that the universe began with and that it can never fully replace. Stars are the great engines behind almost all of this. A star is simply a very large gradient, an object far hotter than the space around it, releasing that difference slowly over billions of years as light and heat. Every gram of usable energy a star releases came from nuclear fuel, hydrogen fusing into helium, formed originally in the earliest minutes after the Big Bang, or synthesized inside earlier generations of stars that lived and died before our own sun ever ignited. That fuel is finite. It is not being replenished anywhere in the universe in any meaningful way. Once a star exhausts its hydrogen, it moves on to heavier fuels for a while, but every stage burns faster and produces less energy than the one before it. Eventually, every star runs out of anything left to burn. The largest stars end in dramatic supernova explosions, scattering heavier elements out into space, elements that will eventually become part of new stars, new planets, and in at least one known case, new life. But even this recycling is not infinite. Each generation of stars converts a portion of the original hydrogen supply into heavier elements that burn less efficiently, or that never burn at all. Every supernova, every stellar death, leaves slightly less usable fuel behind for the next generation of stars to draw from. The universe is not just running out of light, it is running out of the raw material required to make light in the first place. Astronomers estimate that star formation across the universe as a whole peaked billions of years ago and has been declining ever since. Our own era, right now, tonight, sits already well past the universe's most active stretch of star birth. We exist during a slow decline, not a rising tide. Trillions of years from now, the last new stars will form from the last remaining pockets of usable gas, and then no more will ever be born again. The stars that already exist will keep burning for a while, some of them for spans of time longer than the current age of the universe many times over. But even the longest lived among them, the small, slow-burning red dwarfs, will eventually exhaust their fuel completely. When the last star finally goes dark, whenever that happens, in some almost unthinkably distant future, the universe will not go dark all at once. It will fade slowly, unevenly, the way a fire dies down to embers, and then to ash, and then to nothing but cooling stone. Black holes will remain for a while after the stars are gone, slowly consuming whatever matter drifts close enough to fall in, and radiating away tiny amounts of energy through the process known as Hawking radiation. Even the largest black holes, given enough time, will lose all of their mass this way, evaporating completely, though the timescale required is so long it barely fits inside ordinary numbers at all. After that, there will be nothing left but scattered particles, spread so thin across an ever-expanding universe that they will rarely, if ever, encounter each other again. Temperature everywhere will approach absolute zero, evenly, with no differences left anywhere to drive any kind of process, any kind of change, any kind of life. This is the true, final silence. Not the absence of a signal from another civilization, but the absence of any possibility of a signal at all, anywhere, from anyone, because there will be nothing left with enough order to produce one. We exist right now in an early, warm, energetic moment in a story that will eventually cool into something almost perfectly still. The stars overhead tonight are not just distant, they are temporary, burning down a fuel supply that took the entire history of the universe to accumulate, and that can never be replaced once it's gone. Every signal we send, every signal we hope to receive, depends on that fuel still being available, on stars still burning, on civilizations still existing long enough to build the tools required to reach across the dark. The window for any of this to happen at all is not permanent. It is a narrow stretch of cosmic time, bright and active compared to what came before the first stars, and unimaginably brighter than what will remain after the last one fades. We are living inside that narrow stretch right now, tonight, without having chosen the timing, simply born into the era when it was still possible to look up and see something at all. Take all of this together for a moment, and something strange happens. The silence stops feeling like an accident. It starts feeling like the shape of the universe itself, expressed in the simplest way possible. Distance keeps almost everything apart. Expansion is quietly increasing that distance every single year, without pause, without exception. Time keeps almost everything from overlapping, spreading civilizations across billions of years the way expansion spreads galaxies across billions of light years. And entropy is slowly draining the very fuel that makes light, warmth, and thought possible in the first place. 4 separate forces, each one enormous on its own, all pointing in exactly the same direction. Apart. Always apart. Increasingly apart. It would be easy to hear all of this and feel small. Insignificant even. A brief flicker of chemistry on a small rock circling an ordinary star in an ordinary galaxy among 200 billion others, all drifting apart inside a universe that seems built, structurally, to keep everything alone. But there is another way to sit with the same facts. Given everything working against it, given how thoroughly the universe seems designed to keep things separate, the simple fact that anything here noticed any of this at all becomes strange in a different way. Not strange because it should be common. Strange because it should, by every measure available, be almost impossible. Matter arranged itself on this one small planet into something capable of asking where everyone else went. That is not a small thing, even set against a universe this large, this old, and this indifferent. It might, in fact, be the rarest event we currently know of anywhere in existence. Every atom in your body was forged inside a star that lived and died long before the sun ever formed. Carbon, oxygen, calcium, iron, all created in nuclear furnaces billions of years ago, scattered across space by explosions so powerful they briefly outshone entire galaxies. Those atoms drifted for millions of years, cold and formless, before gravity gathered them into a new star and a disk of debris around it, and eventually a small blue planet with the right conditions for something extraordinary to happen. You are not simply living in the universe. You are made of it, quite literally, assembled from material that traveled an almost unthinkable distance and an almost unthinkable span of time before arranging itself, however briefly, into something that could look up and wonder. This happened despite a great filter of unknown location and unknown difficulty. It happened despite distances so vast that light itself takes years, or centuries, or millennia to cross them. It happened despite an expanding universe actively working to separate everything it contains. It happened despite entropy, slowly and patiently draining the order out of everything, everywhere, all the time. Against every one of those forces, here you are tonight, aware enough to consider them at all. That awareness did not have to happen. Nothing in the structure of the universe required it. Stars would have burned exactly the same. Galaxies would have drifted apart exactly the same. Entropy would have crept forward exactly the same, whether or not a single conscious mind ever existed to notice any of it. The universe does not need witnesses. It would have continued, indifferent and unchanged, through billions of years of total silence, if the specific, unlikely chain of events that produced life, then complexity, then intelligence, then curiosity, had simply never occurred. And yet, somewhere, on at least one small world, it did occur. The universe grew a piece capable of turning around and looking back at itself, asking questions no star has ever asked, tracing its own origins back through supernovae and galaxies, and the first fraction of a second after everything began. Perhaps that is the real answer to tonight's question. Not why the universe is silent, but why, against every force working to keep it that way, it is not entirely silent after all. Somewhere, right now, at least one small part of the universe is listening. Whether or not anyone answers, that listening is itself remarkable. A brief candle held up against a darkness built, structurally, to extinguish everything eventually. The silence may never break. The search may continue for another 60 years, or 600, or 6,000, and still return nothing but static, the ordinary hiss of an ordinary universe,
going about its ordinary business of drifting apart. That would not make the search meaningless. It would simply mean the answer, whatever it turns out to be, is exactly as vast and as patient as the question itself. Some things are worth continuing, even without any promise of an answer arriving on any particular night, in any particular lifetime, or within any particular civilization's brief window of existence. The listening itself is the point, in a universe that offers no guarantee of ever being heard back. There are other explanations for the silence, stranger ones, that scientists still take seriously. One is called the zoo hypothesis. It suggests advanced civilizations already know we exist and have chosen not to make contact. Perhaps they observe from a distance, deliberately, the way a naturalist watches a species without disturbing it. Perhaps there is a kind of galactic agreement, unknown to us, that young civilizations are left alone until they reach a certain level of maturity. There is no evidence for this idea. There is also no way, currently, to disprove it. It remains a possibility precisely because silence is compatible with almost any explanation, including ones where someone is out there, watching, and simply choosing not to answer. A darker version of this idea has become known as the dark forest hypothesis. It imagines the universe as a forest at night, full of hunters who stay silent on purpose. Under this idea, every civilization eventually realizes that broadcasting its location is dangerous. Any civilization advanced enough to hear you might also be advanced enough to see you as a threat, or a resource, or simply an obstacle. The safest strategy, under this theory, is silence. Listen, but never transmit. If this is true, the universe could be full of intelligent life, all of it deliberately quiet, all of it hiding from everyone else out of pure survival instinct. Every civilization would be listening, and none would be speaking, producing exactly the silence we observe, not because no one is out there, but because everyone out there has independently reached the same terrifying conclusion. This idea remains speculative, more philosophy than confirmed science, but it has gained serious attention precisely because it offers another consistent explanation for a universe that looks empty, despite the numbers suggesting it should not. There is also the question of what a truly advanced civilization might actually look like from a distance, and whether we would even recognize it if we saw it. Some researchers have proposed searching not for deliberate signals, but for what are called techno-signatures. Evidence of technology so massive, it changes the observable behavior of a star system. The most famous example is the Dyson sphere, a theoretical structure built to capture most or all of a star's energy output, first proposed as a serious idea in 1960. A star surrounded by such a structure would look strange to our telescopes. Its visible light dimmed, while it radiated an unusual amount of heat in infrared wavelengths, the signature of enormous amounts of captured energy being used and released. Astronomers have actually searched for stars matching this exact pattern, scanning hundreds of thousands of stars for the telltale infrared excess a Dyson sphere might produce. A few candidates have appeared over the years. Every single one so far has eventually been explained by something natural. Dust, debris disks, unusual but ordinary stellar behavior. No confirmed Dyson sphere has ever been found, despite systematic searches spanning decades. Other techno-signatures have been proposed as well. Unusual atmospheric chemistry on distant planets, city lights visible on the night side of a rotating world, industrial pollution detectable in a planet's atmospheric spectrum, even artificial satellites reflecting light in patterns natural objects would not produce. Every one of these searches, across every method attempted so far, has returned the same result. Nothing conclusive. Nothing that couldn't ultimately be explained by ordinary physics, ordinary chemistry, or ordinary geology. The universe, examined at every scale we know how to examine it, keeps looking exactly like a universe with no one else home, even though the raw numbers say that should be almost impossible. This contradiction is sometimes called the Great Silence, a term used alongside the Fermi Paradox to describe not just the absence of contact, but the sheer, consistent thoroughness of that absence across every method, every wavelength, every kind of search humanity has managed to attempt so far. Perhaps the true answer involves several of these explanations at once, layered on top of each other, rather than any single clean cause. Perhaps the great filter really does sit partly behind us, in how rarely complex life emerges at all. Perhaps it also sits partly ahead of us, in how difficult it is for any civilization to survive its own technology for very long. Perhaps distance and expansion make even the rare survivors nearly impossible to detect, scattered too far apart, in space and in time, to ever notice each other before one side falls silent again. Perhaps a few of the civilizations that do survive have deliberately chosen quiet, whether out of caution or privacy, or reasons entirely outside human imagination. We do not know which of these is true, or whether the real answer is something else altogether, something no human theory has proposed yet, hiding in a piece of the puzzle we have not even identified. What we do know, measured across 60 years and millions of stars, is that whatever the explanation turns out to be, it produces exactly the silence we have been sitting inside since the very first radio telescope was pointed at the sky. Step back once more, past the searches, past the theories, and look at the sheer scale of what a single night sky actually represents. On a clear night, away from city lights, the unaided human eye can see roughly 2,000 stars. Every one of those points of light is a sun, some larger than ours, some smaller. Most surrounded by planets we cannot see directly, but know almost certainly exist. That is only what a single pair of human eyes can detect, from a single small planet, using no instrument beyond the eye itself. Point a telescope at any dark patch of that same sky, a patch that looks completely empty, and the picture changes entirely. In 1995, astronomers pointed the Hubble Space Telescope at a tiny, apparently empty region of sky, roughly the size of a grain of sand held at arm's length, and left the camera open for 10 consecutive days. The resulting image became known as the Hubble Deep Field. It did not show emptiness. It showed nearly 3,000 galaxies packed into that single tiny patch of sky, each one containing billions of stars of its own. Repeat that experiment across every similarly sized patch of sky, in every direction, and the numbers scale into the hundreds of billions of galaxies, an estimate astronomers now consider a reasonable lower bound for the observable universe as a whole. Every one of those galaxies is a version of our own in miniature. Billions of stars, trillions of planets, an entire history of formation, collision, and slow evolution, stretching back nearly to the beginning of time itself. And every single one of them, examined so far, in every wavelength available to modern instruments, shows the same silence we hear from our own galactic neighborhood. No confirmed signal, no confirmed structure, no confirmed evidence that anything living has ever looked back at us from anywhere within that staggering number of worlds. This is the scale the paradox actually operates on. Not one galaxy, not even a few thousand. Hundreds of billions of galaxies, each one a small universe of possibility on its own, and across every one of them examined so far, the same quiet static, the same absence of anything we can point to and call a voice. It is worth remembering, too, that we have barely begun to look. Humanity has been capable of listening to the sky in any serious way for less than a century. Modern radio astronomy is younger than most of the people who will watch this video tonight. Compared to the age of the galaxy, 10 billion years and more, a century of searching is not even a rounding error. It is closer to nothing at all, a single instant, barely long enough to register on any cosmic clock. If a civilization somewhere sent a signal our way 1,000 years ago, and it is still traveling, we would not know it yet, because it has not arrived. If a signal is arriving right now,
this very night, aimed at a random patch of sky that our instruments happen not to be pointed at in this particular moment, we would miss it entirely and never know we had. The search is not just difficult because of distance or expansion or the sheer number of places to look. It is difficult because we are trying to catch a very specific kind of lightning in a very specific kind of bottle, during a window of time so brief compared to the age of everything around us, that missing it entirely would be the expected outcome, not a surprising one. And still, every year, the search continues. New telescopes, new frequencies, new ways of sorting through the noise, hoping to catch the one pattern that could not have happened by accident. Every failed search adds another data point to an already staggering pile of silence. And still, somehow, the listening continues. Patient in a way that almost nothing else in nature is patient. Holding a question open across generations of scientists who will never personally see it answered. There is a particular kind of vertigo that comes from holding all of this at once. 200 billion galaxies, each one silent. An expansion that never stops widening the gap between everything and everything else. A great filter of unknown location, unknown difficulty, and unknown mercy. An entropy that slowly drains the very possibility of light, warmth, and thought out of existence, one star at a time, forever. None of these facts are comforting on their own. Together, they can feel almost unbearable. The kind of thought that is easier to avoid than to sit with directly. And yet there is a quieter way to hold the same information. One that does not erase the scale of it, but softens the weight. You are here, right now, inside the narrow window when any of this is even possible to think about at all. Stars still burn. Energy still flows. Gradients still exist everywhere around you, powering every heartbeat, every breath, every thought passing through your mind at this very moment. You exist inside the bright, active middle of a very long story, not at its cold, silent end. The heat death of the universe is real, but it is trillions of years away. A span of time so much longer than anything currently alive that it barely qualifies as a threat in any meaningful sense.
The expansion of the universe is real, and it is relentless. But the galaxies closest to us, the ones that actually matter for any near-term sense of scale, are not going anywhere for billions of years yet. The great filter, wherever it sits, has not stopped you from existing, from thinking, from noticing the sky at all. Whatever barrier it represents, you are, at minimum, still on this side of it, tonight, breathing, aware, capable of holding a thought this large without your body forgetting to keep functioning underneath it. That is no small thing, set against everything working against it. The silence out there does not require anything from you. It does not need to be solved before you are allowed to rest. It will still be there tomorrow night, and the night after that, unchanged, unresolved, exactly as vast and as patient as it is right now. There is nothing urgent in it. There is only scale and time, and the simple fact that you happen to be a brief, warm, thinking thing, existing inside a universe built mostly for cold and silence, for now, tonight, breathing quietly in the dark. Think, one more time, about the radio dish, sitting quietly somewhere far from city lights. It is still listening, tonight, right now, while you hear this. Somewhere, a receiver is scanning frequency after frequency, patiently, without complaint, the way it has scanned every night for decades. It does not know if tonight is the night. It has no way to know. It simply listens, because listening is the only thing that keeps the possibility alive at all. Every star above you tonight is doing something similar in its own way, burning steadily, sending light outward in every direction, without any promise that anyone will ever see it, or measure it, or wonder about the world it came from. The light left some of those stars hundreds of years ago. Some of it left thousands of years ago, traveling in silence the entire way, arriving now,
to night, into eyes that only just opened to receive it. None of that light knew, when it left, that it would ever be seen. It traveled anyway. That quiet persistence, light crossing unimaginable distance with no guarantee of ever being witnessed, is not so different from the search itself, or from anything else worth doing inside a universe this large, this old, and this indifferent to whether anyone notices. The silence continues. It will likely continue tonight and tomorrow, and for a very long time after that. But somewhere, a dish keeps turning toward the sky. Somewhere, a light that left its star long before you were born keeps arriving, patient and unbothered by the scale of its own journey. And somewhere, tonight, for a little while, you are the part of the universe that noticed. Consider, too, how strange it is that a species this young has managed to measure any of this at all. Humans have only understood that other galaxies exist for about a century. Before that, astronomers assumed the fuzzy patches of light they saw through their telescopes were simply clouds of gas within our own galaxy, nothing more. It took until the 1920s for Edwin Hubble to prove otherwise, measuring the distance to a faint smudge in the constellation Andromeda and discovering it was not a cloud at all. It was an entire galaxy, far beyond the edge of our own, containing billions of stars of its own. In a single measurement, the known universe grew by a factor that is difficult to overstate. Before that discovery, most astronomers believed the Milky Way was the entire universe. One galaxy, alone, containing everything that existed. After it, the universe suddenly contained not one galaxy, but potentially billions, each one its own separate island of stars, scattered across a darkness far larger than anyone had previously imagined. That single discovery is barely one human lifetime old. Since then, in less than 100 years, our estimate of the universe's size has grown from one galaxy to 200 billion. And our estimate of its age has been pinned down to within a fraction of a percent, using light left over from the very first few 100,000 years after the Big Bang itself. We have measured the expansion rate of space. We have detected the faint afterglow of the universe's earliest moment, still arriving from every direction, billions of years later. We have found thousands of planets orbiting other stars, confirming that worlds like our own are common rather than rare. We have built instruments sensitive enough to detect ripples in space and time itself, caused by black holes colliding billions of light years away.
All of this accomplished in barely more than a single century by a species that did not yet know galaxies existed at the start of it. If a species this young can learn this much this quickly, it raises an uncomfortable question of its own. What might a civilization capable of surviving for another 10,000 years come to understand? What might one capable of surviving for 1,000,000 years build, or discover, or become? We have no way of answering that question because we have no example to study. Every civilization we know of, which is to say the only one we know of, is still well within its first few centuries of technological life, still learning, still searching, still listening to a sky that has not yet answered back. Perhaps that is the most honest thing that can be said about tonight's silence. It is not necessarily the final answer. It may simply be an early chapter in a search that has barely begun, conducted by a species that has only just learned to ask the question in the first place. There is one last thought worth carrying before the recap and the quiet after it. Every civilization that ever searches the sky, anywhere, at any point in cosmic history, faces the exact same silence we face tonight. That shared condition connects us to something, even without contact, even without proof. If another mind, somewhere out there right now, is also pointing an instrument at the dark, also waiting, also wondering why nothing answers, then in a strange way, we are already doing the same thing together, separated only by distance too vast to matter in the moment itself. Two searches, running in parallel, unaware of each other, both patient, both quiet, both hoping without evidence, that the silence is not the whole story. That is not contact. It is not even close to contact. But it is company of a kind, imagined rather than confirmed, and there is something gentle in allowing yourself to hold that thought loosely, without needing it to be proven true. The universe does not owe anyone an answer. It never promised one. It simply exists, vast and old and largely indifferent, following rules laid down before the first star ever lit the dark. And within those rules, somehow, minds keep appearing anyway, keep looking up anyway, keep asking the same quiet question anyway, generation after generation, on world after world, whether or not any of them will ever hear each other clearly. 200 billion galaxies, sextillions of stars, trillions of planets scattered across a darkness too large for numbers to mean much anymore. 60 years of listening, millions of stars examined, one by one, frequency by frequency. Not one confirmed voice. Not one signal that couldn't be explained away. Just static, patient and endless, arriving from every direction at once. A filter of unknown location. Behind us, perhaps, buried somewhere in the unlikely chemistry that first turned matter into life. Ahead of us, perhaps, waiting in the tools every civilization eventually builds and struggles to control. Distances too vast for light itself to cross quickly. There is a particular kind of light worth pausing on before moving further outward. Look up on any clear night, and some of what you see is not, strictly speaking, still there. Starlight takes time to cross the distance between its source and your eye. For nearby stars, that time is short, a handful of years at most. For others, scattered farther across the galaxy, the light now arriving left its source centuries ago. A few of the faintest points visible to the naked eye departed their stars before recorded human history began. The star itself may have changed enormously since then. It may have swelled into a red giant, shedding its outer layers into space. It may have collapsed, detonated, and scattered its material across 100 light-years of surrounding dust. It may, in the most extreme cases, no longer exist in any recognizable form at all. None of that changes what you see tonight. The light left before the ending happened, and it carries no information about what came after. It simply continues, unaware, indifferent, arriving exactly on schedule regardless of what became of its source. In this narrow sense, every night sky is also a kind of archive. It shows the universe not as it is, but as it was, layered unevenly across billions of years of departure times. The nearest stars show you something close to the present.
The most distant visible objects show you something closer to the deep past, a fossil record written in photons instead of stone.
Astronomers have a name for this effect, though they rarely need to explain it twice. Looking outward is the same as looking backward. The farther a light source sits, the older the image it delivers. A galaxy 10 billion light-years away is not being observed as it exists today.
It is being observed as it existed 10 billion years ago, back when the universe itself was still young, still assembling its first generations of stars.
Whatever that galaxy has become since then, whatever it now contains, remains entirely unknown, hidden behind 10 billion years of travel time still left to cross. There is something quietly strange about building an entire civilization's understanding of the universe out of light that is, by definition, outdated the moment it leaves its source. Every star chart is a patchwork of different eras, stitched together into a single sky that never actually existed as pictured. Not at any single moment. Not from any single vantage point. The constellations overhead tonight are not a snapshot. They are a collage, made of stars whose light left at wildly different times, arranged only by the accident of distance and direction, not by any shared moment in cosmic history. Some of the stars forming a familiar shape may have already died. Others, sitting nearby in the same constellation, may still be young,
barely out of formation, with billions of years of ordinary burning still ahead of them. You cannot tell which is which, simply by looking. The light offers no label, no timestamp beyond what careful measurement can extract from it. It only offers brightness, color, and position, the same three clues astronomers have relied on for centuries to reconstruct a story the light itself does not tell directly. This delay becomes even stranger once it is applied to the search for other civilizations. Any signal detected tonight from any star system would necessarily be old by the time it arrived. A message received from a star 1,000 light-years away would have been sent 1,000 years ago. The civilization that sent it might no longer exist. It might have changed beyond recognition, grown far more advanced, or vanished entirely, the way so many things eventually vanish given enough time. Receiving a signal would not mean receiving a conversation. It would mean receiving a message in a bottle, thrown into the ocean by hands that may already be gone, discovered by someone who cannot possibly write back in time to matter to the sender at all. Even a successful detection, the single event scientists have spent 60 years hoping for, would still carry this strange, built-in delay, a gap between sending and receiving that no amount of technology can close. The universe does not allow conversations across these distances. It only allows monologues, sent outward, arriving eventually, answered only after a delay so long that the original question may no longer matter to anyone involved. Consider, next, a different kind of puzzle. One that lives at the smallest and strangest scale scientists have ever tried to study. Black holes are often described simply as regions where gravity is strong enough that nothing, not even light, can escape. That description is accurate, but it hides a deeper problem that has occupied physicists for decades. When matter falls into a black hole, it seems to disappear completely, along with every detail it once carried. The specific arrangement of atoms, the exact history of where that matter came from, all of it appears to vanish behind the boundary known as the event horizon. According to the deepest laws of physics currently understood, information cannot simply disappear from the universe. It can be scrambled beyond recognition, hidden or spread out almost infinitely, but it cannot, in principle, be destroyed outright. Black holes appeared to break that rule entirely, swallowing information and giving nothing back, at least according to the earliest models of how they behaved. Then, in the 1970s, a calculation showed that black holes are not perfectly black after all. They emit a faint trickle of radiation, now known as Hawking radiation, slowly losing mass over almost unimaginable timescales. Given enough time, far longer than the current age of the universe, a black hole will radiate away its entire mass and disappear. The question that has haunted physicists ever since is simple to state and brutally difficult to answer. Does that radiation carry the missing information back out with it, hidden in patterns too subtle for early calculations to detect? Or does the information genuinely vanish, forever, the moment the black hole itself finishes evaporating? Decades of work, involving some of the most demanding mathematics in modern physics, have slowly tilted toward the first answer. Most physicists now believe the information is preserved, encoded somehow in the radiation itself, though the exact mechanism remains only partly understood. The debate is not simply academic. It touches the deepest question physics can ask: whether the universe is, at its core, a place where nothing is ever truly erased. If information really can be destroyed, entire branches of physics built over the last century would need to be reconsidered from the ground up. If it cannot be destroyed, then somewhere, encoded in the faint radiation leaking from every black hole in existence, is a complete record of everything that ever fell inside. Every star that a black hole ever consumed, every planet, every fragment of debris, every trace of any civilization unlucky enough to have built too close to one. All of it, in principle, still exists, smeared out into a form so scrambled that reconstructing it would be almost impossible in practice, even if it remains theoretically possible in principle. There is something almost unbearably strange about a universe built this way. Destruction, in the most literal sense, may not actually be available as an option, not even to the most extreme gravitational force scientists have ever discovered. Matter can be crushed beyond recognition. It can be spread across a horizon so thin that no observer could ever hope to read it directly. But according to the physics now favored by most researchers, it is never entirely gone. Even the ending of a star, pulled apart and consumed by a black hole, may simply be a transformation, not an erasure. Another example of the universe rearranging itself rather than truly losing anything at all. Widen the view again, away from any single black hole, toward the question of how life itself came to exist in the first place. The Great Filter, mentioned earlier, is not a single barrier. It is better understood as a series of barriers, stacked one after another, each one difficult enough on its own to explain a portion of the silence. The first barrier sits at the very beginning, the origin of life itself, sometimes called abiogenesis. Somewhere on the early Earth, roughly 4 billion years ago, ordinary chemistry crossed a line into something capable of copying itself. Scientists still do not know exactly how that happened. They have proposed dozens of possible pathways, tested many of them in laboratories, and reproduced several of the necessary building blocks under conditions meant to resemble the young planet. None of these experiments has yet produced life from scratch. The gap between complex chemistry and the simplest living cell remains one of the largest unsolved problems in all of science. It may have happened quickly, within a few 100 million years of the planet cooling enough to support liquid water. It may have required a rare, specific combination of conditions that occurs only occasionally, even across a universe containing trillions of candidate planets. No one currently knows which of these is closer to the truth. The second barrier came much later, and it may have been even harder to cross. For roughly 2 billion years after life first appeared, every living thing on Earth remained single-celled, simple, and small. Then, in an event biologists still debate the details of, one simple cell appears to have absorbed another, without destroying it, forming a partnership that persists inside your own body at this very moment. That partnership produced the mitochondria, the tiny structures inside almost every complex cell that generate the energy needed for anything larger and more elaborate to exist at all. Without that single, ancient merger, complex multicellular life, including every plant, animal, and human being that has ever lived, may never have been possible. As far as scientists can tell, this event happened exactly once in the entire 4 billion year history of life on Earth. It did not happen twice, and produced two separate lineages of complex life. It happened once, in one lineage, and every complex organism alive today descends from that single, ancient, almost accidental partnership. If it is genuinely this rare, a single fortunate event across billions of years and countless individual cells, then the leap from simple life to complex life may be one of the tallest barriers in the entire filter, taller even than the origin of life itself. A third barrier arrived even later, roughly 540 million years ago, in an event known as the Cambrian explosion. Before that period, life on Earth remained mostly simple, soft-bodied, and slow to change, for well over 3 billion years. Then, within a geological instant, a burst of evolutionary experimentation produced most of the major body plans still found in animals today. Eyes appeared for the first time in the fossil record. Shells, exoskeletons, complex nervous systems all arrived within a span of roughly 20 million years. A blink of an eye compared to the billions of years that preceded it. No one fully understands why this happened when it did, rather than hundreds of millions of years earlier or later. Rising oxygen levels likely played a role. Genetic innovations, allowing far greater complexity in body structure, likely played a role as well. Whatever the full explanation turns out to be, The Cambrian explosion represents another point where evolution could plausibly have stalled indefinitely, producing a planet full of simple organisms forever, with no path toward anything resembling intelligence. Stack these barriers together: abiogenesis, the rise of complex cells, the explosion of body plans, and the picture that emerges is sobering. Each step appears to have been difficult. Some may have been close to unique, events that happened once by chance and never needed to happen again for the resulting lineage to eventually produce something capable of building a radio telescope. If any planet in the galaxy needs to independently cross all three of these barriers in sequence without failing at any point along the way, then complex, intelligent life may be vastly rarer than the raw number of habitable planets would suggest. Trillions of worlds might exist with the right temperature, the right chemistry, and the right amount of time. Only a vanishing fraction of them may ever cross every barrier required to produce something capable of noticing the silence at all. This does not mean the Great Filter definitely sits behind us, safely in the past, with nothing left to fear ahead. It may sit partly behind and partly ahead, split across both directions at once. Simple life may be common, appearing readily wherever conditions allow it. Complex life may be rare, the product of several separate strokes of fortune, each one improbable on its own. And even where complex life does emerge, intelligence capable of building civilization may represent yet another barrier, layered on top of everything that came before it. Every one of these possibilities remains consistent with the same observed silence. The universe could be filled with simple, single-celled life, quietly present on countless worlds, and still produce exactly zero detectable signals. Because signals require not just life, but a very specific, very rare kind of life. Turn now to a different kind of scarcity, one that has less to do with biology and more to do with timing. Even setting aside every biological barrier discussed so far, even imagining a universe where complex, intelligent life arises readily on world after world, a further problem remains, one built entirely out of time rather than chemistry. Civilizations do not last forever. Every civilization that has ever existed on Earth, without exception, eventually changed beyond recognition or collapsed entirely. There is no particular reason to expect an alien civilization to behave differently, especially once it develops technology powerful enough to be detected across interstellar distances. Suppose, for the sake of argument, that a technological civilization typically remains detectable for 10,000 years before either destroying itself, transforming into something unrecognizable, or simply losing interest in broadcasting outward. 10,000 years sounds like an enormous span of time from a single human lifetime. Compared to the age of the galaxy, over 10 billion years, it is almost nothing. It represents roughly 1 part in a million of the galaxy's total history. For two civilizations to overlap, to both be broadcasting or listening at the same moment, they would need to arise within that same narrow, 1,000,000-to-1 window of cosmic time. Miss that window by even a small margin, arrive 100,000 years too early or too late, and an entire civilization could rise, flourish, and vanish again without ever crossing paths with anyone else, anywhere in the galaxy. This is sometimes called the temporal Fermi Paradox, a companion to the more familiar spatial version. It is not enough for life to be common in space. It also needs to be common in time, spread out closely enough across billions of years that at least a few civilizations happen to overlap within their brief windows of detectability. Given how young human technological civilization actually is, radio astronomy for less than a century, spaceflight for less than 70 years, it becomes worth asking how representative this brief window really is. If every civilization in the galaxy has a similarly short window, measured in centuries or millennia rather than in millions of years, then the galaxy could easily have hosted dozens or even thousands of separate civilizations across its history, without any two of them ever existing at the same time. Each one would experience precisely the silence we experience tonight. Each one would search and find nothing, and eventually stop searching, either through extinction or through some other, gentler kind of ending, never knowing that others had once stood in almost exactly the same position, asking almost exactly the same question, separated not by distance this time, but by time itself. There is no way, currently, to test this idea directly. It requires evidence from civilizations that existed in the deep past. Evidence that would have to survive across spans of time so long that almost nothing physical survives intact. Radio signals themselves fade below detectable levels after only a few hundred light years of travel. A tiny fraction of the galaxy's full width. Any civilization broadcasting more than a few centuries ago, from anywhere beyond our immediate galactic neighborhood, would already be undetectable to current instruments. Its signal too faint, too old, too thoroughly scattered by distance to ever be recovered. In this sense, the galaxy's history may already contain the very contact humanity keeps searching for, just not in any form that current technology could ever hope to catch. The evidence, if it ever existed, may have already come and gone, arriving and fading decades or centuries before the first radio telescope on Earth was built to listen for it. All of these threads, the delay built into starlight, the puzzle of information at the edge of a black hole, the layered rarity of complex life, the narrow windows civilizations occupy in time, point toward a single, quieter conclusion. Solitude, in this universe, may not be an accident at all. It may be closer to a structural feature, built into the basic architecture of space, time, chemistry, and probability, rather than a temporary condition waiting to be corrected by a better telescope or another decade of searching. Distance keeps things apart in space. Delay keeps things apart in time, even when a signal does eventually cross that distance. Rarity keeps complex life from arising often enough to fill the available space and time with company. And narrow windows of detectability keep even the rare successes from ever overlapping cleanly with one another. None of these forces requires any single dramatic cause, any single great filter sitting at one specific point, waiting to be identified and understood. They simply describe how a universe this large, this old, and this governed by probability tends to behave by default. Company is not the default state of an existence built this way. Isolation is, quietly, structurally, built into the numbers themselves, long before any particular civilization ever has the chance to rise or fall within them. This is not a comforting thought at first, and there is no need to force it into becoming one immediately. It is, however, a clarifying thought, one that removes a certain kind of unnecessary guilt from the silence. The silence is not evidence that something has gone wrong, uniquely, with this planet, or this species, or this particular moment in history. It is closer to the expected outcome, given everything now understood about distance, time, chemistry, and probability, working together across a canvas large enough to make almost anything rare, and almost everything alone. And yet, within that same structural solitude, something did happen here. Chemistry crossed the line into life. Life crossed the line into complexity. Complexity crossed the line into awareness, curiosity, and eventually into a species capable of building instruments sensitive enough to measure the very forces working against it. None of that was guaranteed by the structure of the universe. All of it happened anyway, against odds that, examined honestly, look very close to impossible. Whatever else the silence means, it does not mean that this outcome was expected, or common, or easy. It means the opposite. It means that whatever is listening tonight, whatever is capable of holding a thought this large without being crushed by the scale of it, is standing on the far side of a genuinely extraordinary sequence of unlikely events, stretching back through billions of years of starlight, chemistry, and time. There is one more piece of the puzzle worth holding. before the numbers themselves take over. It concerns not signals, but travelers, and a particular kind of machine that never needs to. In the 1960s, a mathematician named John von Neumann described a theoretical machine capable of building copies of itself, using only raw material gathered from its surroundings. Applied to space travel, the idea becomes almost unsettling in its implications. A single probe, launched toward a nearby star, could land, mine local material, and construct several copies of itself. Each copy could then launch toward a new star, repeating the process, spreading outward in every direction like a slow, mechanical wildfire. Even at a modest fraction of the speed of light, far slower than science fiction usually imagines, the math produces a startling result. A civilization willing to build even one such probe could, in principle, fill an entire galaxy with copies of it within a few million years. A few million years sounds enormous by human standards. Compared to the age of the galaxy, over 10 billion years, it is a brief instant, a rounding error in the total timeline available. Any civilization that developed this technology even once, at any point across 10 billion years of galactic history, should have had more than enough time to spread its probes into every corner of the galaxy, including this one. We have found no such probe. No unexplained object drifting through our solar system, no artificial signal embedded in the asteroid belt, no evidence anywhere of a machine built by hands, or claws, or something else entirely, from a world we have never seen. This absence has its own name among researchers, sometimes called the silence of the probes. A narrower cousin of the broader silence this entire search keeps circling back to. It sharpens the paradox considerably, because self-replicating machines do not require a civilization to survive for the full length of the journey. They do not need consciousness, comfort, or continued interest from their original builders. They only need to be launched once, correctly, and then left to spread on their own, indifferent to whatever happens afterward to the species that built them. If even one civilization, anywhere across 10 billion years, had built and launched such a probe, the entire galaxy should, by now, show some trace of it. It does not. Every explanation offered for the silence of the probes echoes the explanations already considered for everything else. Perhaps such technology is far harder to build than the simple math suggests, riddled with engineering problems too severe for any civilization to solve in practice. Perhaps every civilization capable of building one chooses not to, out of caution, restraint, or fear of losing control over something built to replicate without limit. Perhaps the filter that prevents civilizations from surviving long enough to attempt it sits earlier than any of us currently assume, closer to the beginning of technological life than to its outer limits. Or perhaps, more unsettling still, such probes were built long ago by someone and simply have not reached this particular, unremarkable corner of the galaxy yet. Still crossing the dark, still years or centuries away from a solar system that has not yet drawn their attention. There is no way to distinguish between these explanations from where we currently stand. There is only the same pattern, repeating itself at yet another scale, at yet another level of technological possibility. A search conducted honestly, thoroughly, and for longer than most of these ideas have even existed as formal hypotheses. And, once again, nothing found. Not a voice, not a structure, not a single confirmed machine, drifting quietly through the dark, built by hands other than our own. Gather every thread considered so far, the delay hidden inside starlight, the uncertain fate of information swallowed by a black hole, the layered rarity of complex life, the narrow windows civilizations occupy in time, and the silence surrounding even self-replicating machines that should, in theory, be unstoppable once launched. And the shape of the answer becomes difficult to avoid. The universe is not simply quiet by coincidence. It is quiet in a way that survives every new theory thrown at it, every new search method devised, every new instrument built and pointed at the sky. Whatever the true explanation eventually turns out to be, it must be large enough and deep enough to explain silence at every one of these scales at once, from the flicker of a single radio signal to the absence of self-replicating machines that could, in principle, have filled the galaxy many times over by now. That is the scale of the question this search has actually been asking, all along, underneath the smaller questions about any one signal, or any one star, or any one civilization. Not simply, is anyone out there? But, given everything now understood about distance, time, chemistry, and the sheer difficulty of persistence, was anyone out there ever likely to begin with? Hold that question gently, without needing to resolve it tonight, and let the numbers close the distance instead, the way they always eventually do. Numbers this large stop meaning very much on their own, once they cross a certain threshold. The mind is built for counting sheep, or days, or footsteps across a room, not for counting light years, or galaxies, or the seconds inside a billion years. Scientists have tried, for decades, to translate these scales into something a human body could actually feel. One common method shrinks the entire solar system down to the size of a single room. Place the sun at one end, roughly the size of a grapefruit. Earth becomes a grain of sand, orbiting a little more than 9 meters away. Neptune, the outermost planet, ends up nearly 300 meters from that grapefruit, well outside the room, outside the building, out past several city blocks in most versions of the model. And that is only the solar system, a single star with its handful of orbiting worlds. The nearest other star, on this same shrunken scale, would sit not down the street, and not across the city, but on the other side of an entire ocean, thousands of kilometers away from the grapefruit representing the sun. Shrink the galaxy itself down to the size of a dinner plate, and the sun becomes a single point too small to see without a microscope. One among roughly 200 billion identical points scattered across that same plate. Zoom back out, and that entire plate, galaxy and all, becomes one indistinguishable speck among hundreds of billions of similar specks, scattered across a darkness too large for any scale model to represent honestly at all. Every attempt to shrink the universe down to something graspable eventually fails the same way. The numbers simply outrun the metaphor, no matter how carefully it is built, no matter how patiently it is explained. This is worth remembering, gently, as the final tally approaches. The figures that follow are not exaggerations, and they are not meant to overwhelm. They are simply what the universe actually measures out to. Once every instrument, every calculation, and every careful decade of observation is added together into a single, quiet accounting. Before that accounting begins, it helps to remember why it matters at all. Beyond the raw scale of the digits themselves, every number that follows describes a gap in space between one star and the next, a gap in time between one signal sent and the same signal finally received, if it is ever received at all. A gap between what a civilization is capable of building and what a civilization is capable of surviving long enough to finish building. None of these gaps are personal. They are not aimed at any one species, any one planet, or any one small, curious mind lying awake tonight, turning them over. They are simply the terms of the universe as it happens to be built. The same terms every star, every galaxy, and every possible listener has always operated under, without exception, since the very first moment there was anything at all to measure. Think of it less as a warning, and more as a kind of inventory, the way a person might walk slowly through a large, quiet house before turning off the lights for the night. Room by room, distance by distance, force by force, not to be frightened by the size of the house, but simply to see it clearly, once, all the way through, before resting inside it. The house is very large. It always has been. Seeing it clearly does not make it any larger than it already was. It only makes it a little easier to finally set down and let the numbers themselves take over from here. Carrying that context forward, the final tally can begin. They begin, as they always do, with the very first distance that separates one small, quiet world from anything else it might ever hope to reach. 25 trillion miles to the nearest star. Thousands of light years to almost everywhere else. An expanding universe, pulling galaxies apart a little more every year. A cosmic horizon closing slowly, permanently, on everything beyond our own small corner of space. Entropy, draining the order out of every star, every gradient, every possibility of warmth or light or thought. A heat death trillions of years away, patient and certain, waiting at the end of everything. Four forces: filter, distance, expansion, entropy, all pointing the same direction. Apart, always apart. And still, somewhere in the middle of all of it, matter arranged itself into something capable of noticing. A small, warm, thinking thing on a small, warm, thinking planet, circling an ordinary star, in an ordinary galaxy, among 200 billion others. Improbable, brief, real. For now, tonight, the silence is not a message meant for you. It is simply the sound of a universe built, from its very first instant, to keep almost everything apart from almost everything else. You are not required to solve it. You are not required to carry its weight past tonight. The dish will keep turning. The stars will keep burning for a while longer yet. The light will keep arriving from senders who never knew if anyone would be here to receive it. We are the universe noticing itself. Brief sparks of awareness, scattered thin across an ocean of darkness. Each one lit for only a little while. Tonight, quietly, without needing an answer, you were one of them. Let the silence be what it is. Vast, old, unfinished. Not empty of meaning, only empty of voices we have found so far. Somewhere above you, a signal that may never arrive is still crossing a distance too large to imagine, sent by someone, or no one, toward a receiver that may or may not still be listening when it finally gets there. You do not have to wait up for it. The universe will keep expanding, keep cooling, keep drifting toward its own long, slow quiet, whether or not you are awake to watch it happen. Rest now, inside this brief, warm moment, in a universe built mostly for cold and silence. Let the dark outside your window be the same dark that stretches between every star, every galaxy, every unanswered question, drifting quietly through the night. You are here. That was never guaranteed. Let that be enough, for now, as the silence continues, patient and endless, all around you.